Well, given the low fertility rate in Japan and longevity that's among the highest in the whole world, Japan has one of the oldest age structures that the world has ever seen, and the population is currently declining. So from a population that only recently was a little over 120 million, it's projected to go down to 87 million by 2060, and to have over 40% of the population that's over age 65. So one of the highest total dependency ratios that's ever been seen, about one elderly dependent for every worker in the population. So this has many social and economic implications, and it would help policymakers to know something about the health of the future elderly population, to plan for medical spending and long-term care spending and other government programs. Indeed, current projections suggest that the percentage of the GDP in Japan that's spent on medical spending and long-term care may go up to almost 20% of the total GDP. So that's a very significant number. The future elderly model is a demographic and economic microsimulation model that's used to project the health and functional status of an elderly population into the future. And it was developed originally for the United States by a team of researchers led by Dana Goldman and Jay Bhattacharya. And several countries have used this model to tailor to their own populations. As this project, we're tailoring it to Japan. So the model uses a microsimulation, as I mentioned. So it takes a population of age 50, 51 in a given year, like 2014, and projects the probability of dying by the next year and what the health and functional status in the next year will be, and then repeats that for many years into the future, also resampling the population that will age into the model, age 50, 51, in that year. Well, we used a combination of many different data sets under the leadership of Jay Bhattacharya, mentoring a whole team of researchers. We looked at the Japan study of aging and retirement, known as JSTAR, for our primary data set. We also used vital statistics, and because JSTAR only includes people up to, the mid-70s, we include another data set from Nihon University that has 80-year-olds and above, with a very significant population for Japan. And we took these data sets and estimated the relationships so we would know the evolution of health over time for the population. And we also did a kind of innovative mathematical model to try to estimate cause-specific mortality rates. We have about 19 different health conditions, and we know their prevalence given the JSTAR data in the population in question. But only from the vital statistics data for Japan do we know mortality. So we use an innovative way of looking at these two, prevalence in the population and mortality, to estimate disease-specific mortality. So for example, you would say that cancer is a very common cause of death, but is not so prevalent in the population. But hypertension is very prevalent in the population and not often listed as a leading cause of death. So our model looks at those two things and matches them so that we have cause-specific mortality for each year projected with the health and functional status of the population. Well, we used the model to project population for Japan going forward, and we compared that to official Japanese projections of the population. Most simulations just look at the population by age and male and female. Our model is specifically developed to look at health of that population, but it's important to double check and just see we're getting what most people would project for total population. And you can see from our figures that we do match pretty closely the projections that have been developed for Japan. With some differences, we're projecting that more people will live into older ages, and there'll be more people with functional limitations in the population of the elderly in Japan. And some of our projections show that some of the common chronic diseases will increase, heart disease and diabetes, prevalence of cancer not necessarily because it continues to be fatal. Although one of the benefits of having a microsimulation model is that you can simulate changes in technology. So what would happen if there were a cure for a particular kind of cancer, or if we could cure Alzheimer's disease, or all Japanese, particularly men, stop smoking? What would that imply for the future elderly, and importantly for medical spending and long-term care spending and disability rates? So one of our preliminary results relates to disability, and we find that about a third of the Japanese elderly population will have a functional disability. That's a limitation in activities of daily living by 2040. And that is a substantial increase. It's largely driven by increases in the age within the 50 and over population, so more of the oldest old population. But there's some increase in age-specific disability as well. And so this gives some information that prevention of and healthy aging will help to reduce disability, but those effects may be limited because of the increase in the oldest old in Japan's future elderly.